In this video, we're going to continue to study how two triangles can be proven congruent. And in this case, it's a special triangle. It's right triangles. Right triangles tend to be a lot easier, as you can tell from here. We're going to learn this HL congruence theorem, which states if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of the second right triangle, then the two triangles are congruent. And the symbol is here. So if ABC, triangle ABC and DEF are right triangles, and if AC is congruent to DF, AC is the hypotenuse, DF is the hypotenuse, and then if one of the legs are congruent, BC and EF are congruent, then we can draw the conclusion triangle ABC, has to be in that order, would be congruent to triangle in the same order, DEF. Let's look at this example. Two triangles. Is it possible to show that they're congruent? So first of all, what's given is GJ is congruent with KH. So that's given, right? And that's a leg. And also we should point out that angle G is congruent to angle K because they are also, they're right angles. So we have a right angle situation. So we already know one leg. All we need to know is the H. And the H is the hypotenuse, which is JH. And the two triangles share the same hypotenuse. And therefore, we can say by reflective property, reflexive. There we go. Reflexive property of congruence. We can say that JH is congruent JH, and therefore by HL congruence theorem, we can draw the conclusion that triangle JGH is congruent to triangle HKJ. Notice that my order is different from their orders. If you want to use their congruence statement, that's fine too. But because I swapped J and G together, I have to swap H and K together as well. Orders do matter. Let's look at this example. Use the information in the diagram to prove these two smaller triangles are congruent. PQR is congruent to PRS. So first, we always start with the information that's given. We're given two pieces of information, and it should be listed here. So before I even use my brain to analyze it, I should write down what is given. And then see what we can derive from the given situation. So if PR is perpendicular to SQ, and that's given, we can draw the conclusion that these two angles are right angles. And that's because perpendicular lines form right angles. And because we also know if it's two right triangles, we can use HL. And if these two are congruent, this is my H. This is my hypotenuse of each triangle, PS and PQ, right? And then I just need to state that PR is congruent to PR because that's by reflexive property of congruence. Now I have my leg are congruent as well, and therefore we can draw the conclusion that the two triangles are congruent, and that's because of HL theorem of congruence. Here's another example. Does the diagram give enough information to prove that triangles are congruent? If so, state the postulate or the theorem you would use. So let's look at this one. I put this here so that you can just fill out the forms. We have to list the congruent sides and angles and see if there's a theorem or postulate we can use. So we can see that if I use this, these two are congruent and these two angles are congruent. So I have angle CAD, angle CAD, and angle CAB are congruent to each other. I also have angle CDA is congruent to angle CBA. Right, the blue dots are congruent. And I have AC is congruent to AC. These two segments are congruent because of reflexive property. So I can use, I have AAS. I can use the AAS congruence theorem. Let's look at the second one. I have one side that's given, that's GF, is congruent to GH. And I have an angle F is congruent to angle H. And then I have another side, GE, is congruent to GE, right? Oh, don't forget the line over. Just a side note, if I say GE and GE are congruent, I'm talking about their length, their width, their shape, everything is the same. But if I just do GE equal GE, notice I don't have the little bar on top. That means I'm not talking about shape. I'm only no shape. I'm only shape. I'm only talking about length. Okay, so that's called measure. That's a side note. So coming back to question B, I now have, looks like I have two sides and an angle. Do I have two sides and the angle? But the angle is not concluded. So if the angle is concluded, I would have SAS. In this case, it's not included, so I cannot use SAS. And there's no SSA congruence postulate, okay? This is really important. Whoops. This is really important to note that there's no SSA. There's no SSA congruence postulate or theorem. We can talk about it in class why there's no SSA, because there's no guarantee that the two triangles are congruent. So SAS right now, or AAS is the only way to go. Let's look at this one. We have to prove that these two triangles are congruent. So ST is congruent to VW. So that's given, right? Because of these tick marks, that's given. Angle V and angle S and V are congruent. That's also given because of the tick marks. Okay, so I've got one side, I've got two angles, T and V. T and V are also congruent. Interesting. So that's given. T and V are given too. And then UVW, so if UVW is congruent, that's the definition of equilateral triangle. Meaning if all three sides, it's given all three sides are congruent. If all three sides are congruent, notice that the side and the opposite angle is a corresponding pair. This side, VW, and angle V is a pair. And angle W corresponds to UV. So if all three sides are the same, all three angles must be the same. So equilateral triangles are V and W, they are congruent. So they are also congruent. So therefore, if T over here, T and W are congruent because angle T and angle V, angle T and angle V, we already know that's congruent, and then angle V is congruent to angle W. Therefore, because of transitive property of congruence, we can draw the conclusion that angle T and angle W is congruent. And that's why I can say triangle TRS is congruent to triangle WUV by ASA. So because I have ASA or ASA on this side. Okay? Finish these follow-ups, and if you have questions, bring it to class and we can discuss it in class. All right, guys, I'll see you soon.